Welcome. I'd like to start our discussion of conic sections with a bit of a broad overview. We're going to study several related ideas. We're going to look at circles, ellipses, parabolas, and hyperbolas. So how are these concepts related? Well, they're all examples of conic sections. What is a conic section? Well, the idea is that all of these two-dimensional objects can be derived from the same three-dimensional object. So the central concept for us will be that of a double cone. So we'll think about this as living in three dimensions. And what we do to construct conic sections is we imagine taking a two-dimensional plane and slicing through this three-dimensional object. So let's think about the different ways this could happen. One of the nicest things that could happen is that I slice a plane through this in a way that is perpendicular to the base, just like this. So if I slice this way, what kind of shape am I cutting out of the section? Well, it's going to cut out a circle for me. So this will generate a circle. But things might not be so nice. I might cut at an angle. For example, something like this. And in this case, I would generate an ellipse. What else could happen? Well, I could cut in a way like this, where I don't slice through two sides. I only slice through one. And this would generate for me a parabola. And the last situation would be if I sliced like this. And for this would generate the most subtle case, which is what's called hyperbolas. So it would look something like this. So the different ways of cutting this three-dimensional cone give me different types of two-dimensional objects to study. We have 4 submodules, one for each of them. We'll start with the most simple, which in my opinion is circles. Then we'll look at a natural generalization of circles, ellipses. So I'll make a remark that an ellipse generalizes a circle, meaning that all circles are ellipses. Then we'll look at parabolas. I consider that to be a bit more straightforward than hyperbolas because we already have some idea of parabolas from our study of degree 2 polynomials. And then we'll look at hyperbolas, which are probably the most challenging and conceptually difficult of these topics.